last page. It'd be like this. What I want you to do is I want you to go simplify. So that's just your basic rational, right? Multiply, divide. What's our first step? Because I find that if you can do your first step, everyone can do it. If not, they just sit there and like, I don't know what to do. Okay? What's the first step for all three of these? We just did these. GCF, and then difference of squares, everything. That means all the numerators, all the denominators, right? That's the first step. Just like fractions, multiplication, division in them, you'll try and simplify them and then put them together, right? So GCF, difference of squares, everything. All the numerators, all the denominators, correct? Okay, adding and subtracting. What's the very first step for adding and subtracting fractions? Because we use the same rule. In order to add and subtract fractions, what's your very first thing you need? Starts with a C. Yeah. Common denominators. You can't add or subtract any type of fraction or rational without a common denominator. So they're very different first steps, correct? So when you see a simplify, multiply, divide, GCF, different squares, all the numerators, all the denominators, first step. For adding and subtracting, our first step is common denominators. We can't add and subtract anything. It's like if I gave you a pizza cut out of 8 pieces and another one cut out of 3 pieces, and I said, this so much is left, can you tell me if it fits in a box? That's really hard to do. But if I cut the 8-piece one out of 8 pieces and the other one out of 8 pieces, it's a lot easier to figure out how many are left, correct? When they're out of the same amount, meaning same denominator, same amount cut into. So the first ones are going to be easy, because what do they have? Common denominators. Do you think they're going to be that nice? No. Why would I give you the first example with common denominators in it? Because I'm teaching you how to deal with the tops, with the numerators once you have common denominators. So it's not so overwhelming to make a common denominator and then da, 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 right? So this first one, I'm giving you common denominators. So this pizza is out of 3 pieces, this pizza is out of 3 pieces, and I'm going to try and subtract them. Can I do that if they're both out of 3 pieces? Yes. As long as your denominators are the same, it's really easy to subtract. So we go equals, and then some people say 0 or 6 if we're adding. What's the point of getting a common denominator if you're now going to add them or subtract them? There would be no point, right? So the reason why you get a common denominator is you write everything all over that denominator, right? So we're going to get 2x minus x all over what? 3. What's great about this one? There are no non-permissible values. Why are there no non-permissible values? There's no variables in your denominator. Exactly. So it's all over 3. And then I math. What's 2x minus 1x? And this is where people's skills of combining like terms really shines or is sad. There's no in between. You get 1x. Think about it as xylophones if you have to. I have 2 xylophones. I have to take away 1 xylophone. I'm left with 1 xylophone. Done. Yeah, just treat them like xylophones. 2 xylophones minus 1 xylophone. So if I have an x squared, is that a xylophone? No. So can I combine it with the xylophones? No. That's why like terms matters, right? Okay, B, we have a common denominator. So we're going to write it all over one of them. All over 5. Now I get 2a minus 3, and then I'm going to add this binomial to it. So I'm going to add the 9a, and I'm going to add the positive 1. And when I add, it doesn't change anything, right? Because when you're adding, you're just adding. Subtracting is a different story. When we subtract a binomial, there's a catch that everyone makes an error. Do I have any non-permissible values when my denominator is 5? No. But I do need to collect like terms now. So I have 2 apples and 9 apples. How many apples do I have? 11 apples. And then I have minus 3 nothings. plus 1 nothing is minus 2 nothing. I'm done. You try C and D. Go. So here we have equals all over 4. Plus signs have no problems. We have 3x plus 1x. So 3 xylophones plus 1 xylophone is 4 xylophones over 4. Do I have any non-permissible values? Can I do anything still? Yeah. So if you can simplify, you still do. That's a monomial, right? So my answer is x. D, you have to watch yourself when what you're subtracting is a binomial. So if you look at D, 5y minus 1, and then we subtract 4y plus 7, that's a binomial behind, correct? That 4y plus 7? You have to subtract the entire binomial, not just the 4y, which is what you will do, and it's a common error, and your answer will be there. So you have to watch yourself. If you just subtract the 4y and you don't remember to subtract the 7, guess what's going to happen? You're going to think you're right, because the answer will be there, but you are wrong, and you won't catch it. Okay? So, this equals all over 6. So we get 5y minus 1, and then I have to subtract the 4y and the 7, correct? I have to subtract both of these. So I'm going to get minus 4y minus 7. If you're someone who did plus 7, you should star, highlight, remind yourself, subtract the whole binomial. Okay? And then we're going to get like terms together. So we get 5 yaks minus 4 yaks is 1 yak. A yak. You know what a yak is. You can use a yam if you so choose, or yellow parrot. I don't know. Negative 1 minus 7 is negative 8. Can I take anything out of y minus 8 and 6? Y minus 8 and 6? Y minus 8? It's a binomial. It's sewn together by titanium string, correct? So, boom, boom. So can I take anything out of the y minus 8, which is a binomial, with the bottom, which is a monomial? We're done. Yeah?
Negative 1 minus.
All right. What's the problem with number 2 now? You don't have common denominators. You still don't have non-permissible values, because I'm moving up slowly here, right? Everyone's paying attention. So, what's common between 4 and 3? 12. So what you do to the denominator, you have to do to the numerator. You guys know why? Or you just trust your teacher? You just trust your teacher. Most people do. Okay, this is why. Actually, most of the time teachers explain, but you just then ignore them and just trust your teacher. Okay, so if I multiply this by 3 to make it a 12, I can't just do that. I would change the whole fraction, right? So when you do it to the top, it actually makes it not simplified, it actually makes it bigger, correct? So if you think about it, what's 3 divided by 3? 1. Can I multiply anything by 1 and it doesn't change anything? Yeah, what's 5 times 1? 1. 5 times 1 is 5. Wow. You good, me bad. 5 times 1 is 5. Didn't change it. What's 5 times, or 1 times smiley face? Smiley face. Doesn't change it. So the thing here is, I'm just expanding this, so instead of simplifying, I'm just making it bigger. A bigger fraction that means the same thing, right? 3 out of 4, 3x out of 3. So let me show you on a pizza. So if this is my pizza, and I have 1 out of 4 slices, correct? If I want to make it out of 8 slices, I'm going to multiply the bottom by 2 to make it out of 8 slices, correct? But I also have to do it to the top, because that 1 slice is going to become how many slices? 2. So what you do to the bottom, you have to do the top, right? Because you're making that bottom be out of 8. Well, you now have to make the top be out of 8 as well. Do you know what I'm saying? A lot of us only think about the bottom being out of 8, but you're actually making the top out of 8 as well. Make sense? All right. So Here we're going to get that minus x over 3. And what do we have to make this multiplied by now? 4. And then what I do at the bottom, make this out of 12. So I have to also make this out of 12 by multiplying it by 4. So on the top, I'm getting 9x out of 12 minus sign. And then on the top of this one, I'm getting 4x out of 12. And it equals something out of 12. So now we have that common denominator. We can go 9x minus 4x. And write it all over 12. What's 9 xylophones minus 4 xylophones? 5 xylophones. Now the 5 and the x and the 12 are all monomials. So if I had something common, I could cross them off, correct? But do I? No, so I'm done. I don't need non-permissible values because it's out of 12. Try B and C. So a lot of people think you need to change both. So they'll make it be 18 or something like that. If you do make it be 18, then you're going to have to reduce it in the end. Okay? So for B, what do we need to do? Yeah. First fraction can just be multiplied by 2 and make it a 6. So we're going to get 3a minus 1 over 3 times 2 plus 4a plus 5 over 6 just stays the same. And so we're going to get 6a minus 2 all over 6 plus 4a plus 5 all over 6. And then because we have a common denominator, we can write it all over 6. So we're going to get 6a minus 2 plus 4a plus 5, because the plus sign doesn't matter, it doesn't affect the binomial at all. And then we're going to collect like terms. So we get 6 apples plus 4 apples is 10 apples. Minus 2 nothings plus 5 nothings is plus 3. And then that is a binomial. True? 10a sewn to the 3. 10a sewn to the 3. That's a binomial. The bottom is a monomial. So for those of you who want to try and divide that 6 out, can you? No, it can't get any better than that. Top is a binomial. Bottom is a monomial. Good to go. No non-permissible values, no restrictions, because there's no variable in the denominator. That's it. Does the 10a plus 3 need a bracket around it? No, it doesn't. I'm just putting a bracket around it so you guys don't try and cancel things with the 6, because it's the thing you have in your soul. You think it needs to be simpler. Okay? Binomials, monomials cannot cancel each other out. All right. C, 8 and 3. We can make them both be 24. You can't make it smaller. 8 times 3, 3 times 8, right? So we're going to get 8y minus 3 over 8. Multiply this one by 3. Minus 2y plus 1 over 3. Multiply this one by 8. So I'm going to get 24y minus 9 over 24 minus 16y plus 8 over 24. Now it's all over 24 because we have a common denominator, but we have to watch ourselves with the minus sign in between, because what's behind the minus sign? A binomial. When you have a binomial behind it, you have to remember to subtract the entire binomial. If you subtract the first part but not the second part, you will feel confident in your actions because your answer will be on the test. And it will be wrong, and you won't even know it's wrong. Okay? So we need to remember that step. And why are we remembering that step? We're remembering that step because mathematically we should understand that we are subtracting this whole thing, correct? We're subtracting that whole thing. So we're going to get 24y minus 9, and then we're subtracting the whole thing, both of them, not just the 16, correct? Because whoever follows behind a minus sign has to be subtracted. So it's not a memorization tactic, it should just make sense to you, right? So we're going to subtract 16y, and we're going to subtract a positive 8. So technically anything behind that subtraction sign changes signs. Then we collect like terms. 24 yaks minus 16 yaks is 8 yaks. Negative 9 nothings minus 8 more nothings is negative 17 nothings. This is a what? Binomial. Some people think the y is only attached to 17. No, there's 8 y's, right? So some people are like, but Mrs. Lepp, I don't get why when it's 8y, it's a monomial, but 8y minus 17, the 8's attached to the y. How can we? Because it's 8 y's, right? We have 8 yams. 8 yams minus 17 nothings. That's a binomial. They're attached. And then over 24. Can I take something out of the 8y minus 17? No. Can I cancel anything off? No. Binomial, monomial. Same. The only way I could cancel something, everyone paying attention, is if I could take a GCF out of 8y minus 17. If I could take a GCF out, that GCF would be a monomial, and then it could cancel the monomial. Right? Yeah?
If you have, like, if you're subtracting the whole thing, how come you don't end up with 1 denominator if you're doing 24 minus 24?
Because we're making a common denominator. Like, for example, I'll go back to pizza, because pizza always makes sense more than stupid x's. So say I have this, and I'm subtracting, then that's the same size. Not that great. Ooh, that's crap. Never mind. Try again. Oh, it deleted the whole thing. Great. You know what? That's probably a good chance going to happen. I need more pizza on this side, sorry. Okay. So this is 3 out of 4 pieces on the same size, pretend, pizza, where I'm going to subtract what? 1, 2, 3, 4, 5 out of 8. We agree?
Yeah.
Okay. I'm going to cut this into 8 pieces so that I can actually subtract them. Which when I cut this into 8 pieces, I multiply this by 2, multiply that by 2. So I'm going to get 6 out of 8 pieces minus 5 out of 8 pieces. So how many pieces do I have left out of not 0 pieces? So if I keep the 8's here, I have to keep the 8's there for the same reason. This just makes more sense because pizza and the other ones with x's, and you're like, what the heck? So when you make that common denominator, you're making it so that you can actually subtract and add. So you just keep it. Make more sense? Okay. All right. Boom. Next page. So many pizzas, so little time. All right, you try this one. The only difference between this and the first example is you're going to get what in the bottom? Restrictions, right? But you still have common denominators, so you're going to write them over that one denominator. So these are all over x, so I get an x in the denominator. The catch with adding and subtracting is you can state your restrictions at any point in time as long as you state them before you cancel off. So if in the end you could, like, hey, you had a 2x plus 1 and a 2x plus 1 and they could cancel off, you have to state your restrictions before you cancel. That's just the rule of restrictions. Okay? So with adding and subtracting, you could state them later than as you do in like multiplication and division. But you have to state them before you cancel, and you have to state them before the end for sure. Okay? So here, I would get 2 plus 7 minus 1. 2 plus 7 is 9, minus 1 is 8 over x. And then I have to follow behind with x can't equal 0. Okay, this one we have a 2a and 2a, so we know it's going to be all over 2a, which is a monomial. Then we're left with 5a plus 3 plus a, and then plus a negative 6. And so we're going to get all over 2a. 5a plus a is 6a. Plus 3 minus 3 is minus 3. Now, a lot of people will stop here, but can we do something to that numerator? Well, we can. It's a binomial. What can we do to it, though? Can we take something out of it? Yeah, we can reduce it. So we can take out a 3, and then we'll be left with 2a minus 1 over 2a. Now, some people want to try and cancel that 2a off with the 2a in the top. Can we do that? The top's 2a is attached to a minus 1 is a binomial. The bottom 2a is a monomial. So can they cancel? Can it be any better than this? No. We have a 2 and an a by itself, so we just have to go a can equal 0. As good as it gets. So I find either people can't start the questions, and that's where they go completely downhill, like they just like, I got nothing. Or they get to the end and the answer is there and I'm like, yes, box it. And then you go like 5 more steps and all of a sudden you have like the answer is 7. And I'm like, pardon? Like, how did that happen? So like you guys like cancel more things than you can't cancel. That's what I get. Or some people never GCF in different scores and they just cancel everything off at the beginning. And they write 8. And I'm like, I don't even know how that happened. Yeah.
So you can get all the way to like your final answer and then do MPVs?
As long as you state your NPVs before you cancel. So if your final answer made you cancel before then you would have to state NPVs before it. But if your final answer, nothing cancels off, yeah, you can wait till the very end. The key thing about NPVs for the entire unit is they need to be stated before you cancel. So, yeah, so if at any point in time you go to cancel, you slap your hand and you say, state NPVs. So if you never cancel, then you can state them at the very last step. Yeah. Okay, this one, we get a 3y minus 1 in the numerator and in the denominator, and in the numerator we're actually going to get 3y minus 1. So these ones are going to completely cancel off, correct? They match. If we cancel them off before we state NPVs, we're in trouble. So I'm like, oh yay, binomial, binomial, I can cancel them. I slap my hand and I say, state my restrictions, state my non-permissible values. So I get 3y minus 1 can't equal 0. 3y can't equal 1 because I'm going to add it over. And divide by 3, y can't equal a third. So these cancel off. When they cancel off, what am I left with? 0 or a really large 1, correct? Because what's 3 divided by 3? 1. 5 divided by 5? 1. 7 divided by 7? 1. 3y minus 1 divided by 3y minus 1? 1. And then we have to go y can't equal a third. Yeah? All right. D, same thing, but we have to watch the subtraction of a binomial. So we're going to get it all over x plus 3. Then we're going to get 4x plus 10 minus 2x minus 4. And so we're going to get x plus 3 in the denominator as our binomial. And then in the numerator, we get 4 xylophones minus 2 xylophones. It's 2 xylophones. And then 10 nothings minus 4 nothings is 6. You have to remember to subtract that 4, right? Because you're subtracting. If not, you'll get 14, and then that answer will be there and it'll be wrong. Okay, can I do anything to this numerator? Take out a positive? Then you get negative x minus 3. So we're going to take out a 2, and we're going to be left with x plus 3. And then we're going to take, and then we have an x plus 3 in the bottom, and we know they can cancel. But before they cancel, we slap our hand and we say what? NPVs. And what are our NPVs? X plus 3 can't equal 0, so x can't equal what? Negative 3. These cancel, and I'm left with 2, comma, x can't equal negative 3. Then here's where life actually gets to more so what we're going to be doing. What's the catch here? We don't have common denominators, and those denominators have what's in them? Variables. Okay? Now, monomial denominators are really easy. Please, in order to not get them wrong, please, when you have a monomial denominator, put your numbers in, like put the monomial in brackets. So like separate those things. It'll make your life easier, trust me. Okay, so how I would do this is I would go 5 over 3p. Okay, plus 2 over 7p. I understand this looks ridiculous, but it will help you. Because ultimately we need a common denominator, correct? What do both of these denominators have? P's in brackets, yes? So do I need to put p's on either of these? That's already good. What do we just need to add? Yeah, common denominators by adding what? 3 and 7, because what is our common denominator going to be? 21p. The p just happens to already be there in both, correct? So some people will multiply by 7p and 3p. Why? P is already good. We don't need to make this bigger, okay? So we're going to just multiply this one by Multiply this one by 7 to make it be 21p, and multiply this one by 3. So we're going to end up with 35 all over 21p plus 6 all over 21p. Now, do we have a common denominator? Yeah, you write it all over 21p. What's 35 plus 6? 41. At minimum, guys, there's such little that I ask of you. When I give you notes that are typed, what did I ask, possibly? That you fill them in with your own pencil. Because I'm writing every single day. So it's not like I'm not doing it. So if I can do it, you can do it too. I'm old, you're not. P cannot equal what? 0. 41 and 21, I can't take anything out of. So these are all monomials, correct? Try it out. So we have 3y and 5, which because they're monomials, we can make that be 15y. So we have 1 over 3y, and then we're going to multiply that by 5, make 15y. And then we have 6 over 5, and we're going to multiply that by 3y to make 15y. So we are left with 5 over 15y plus 18y over 15y. Then we write it all over 15y. And then you get 5 plus 18y, which is a binomial, correct? So that doesn't match anything in the bottom. So that's staying for life. And I have to follow behind with y can't equal 0. Do I need the brackets in the numerator? No. Are they there to make you stop canceling off illegal content? Yes. But you don't actually, the unit exam multiple choice will not have brackets around them. Okay, this one. We're going to multiply this one by 2 to make 6x. So we're going to get 2x minus 5 all over 6x minus this is not a 5y, it's a 5.
Why is there y in the numerator? Oh, no.
It's just 5, not a y. Okay, then we get 6x minus 4 over 6x, and then we're going to get all over 6x, 2x minus 5 minus 6x plus 4 equals 2 xylophones minus 6 xylophones is negative 4 xylophones. Negative 5 plus 4 is negative 1 over 6x. Can I do anything to this binomial? We can take a negative 1 out, but it doesn't change anything. X can't equal 0. We'll finish up D tomorrow, and then tomorrow we also go into binomial denominators that are not the same.